Hey, Wheel of Fortune. Anybody remember this show? Well, I do. I remember people spinning that wheel, and you'd watch to see if it would land on money or bankruptcy. Of course, if it landed on money, they still had to guess a letter of the phrase and get the phrase right to get the money. But still, the premise was, hey, don't land on bankruptcy. Try and make as much money as you can. So let's use a little bit of this Wheel of Fortune fame to learn a little bit about probability. Okay, here's the spinner. Let's spin it and see what we wind up with here. Well, it looks like I wound up with $700. I gotta guess a letter. Was that good, bad, or should I risk it? I'm not sure. There's actually some math that could help me figure out if it's worth the risk or not. And it has to do with finding out a few different pieces of information. So let's take a look at that information, and then maybe we can come back and decide if it's worth the risk to keep spinning, or if we should stop and maybe pass along to the next person. So let's see what we have to learn. Alright, to really understand the probability and understand your chances of, losing all your money or maybe getting an opportunity to win, here's a few things you want to pay attention for. The first is sample space. Now, a sample space is basically everything that could possibly happen. So you see here the official definition is the set of all possible outcomes of an event. Well, think back at the wheel. There's different amounts of money that you could win. Were a couple places where you could go bankrupt. There was a lose a turn. There was actually a free spin as well in case you needed to use that for another turn. All the things that could possibly happen, that's what you count as a sample space. Now, the next thing is a simple event. Okay, that's only one possible outcome. So, for example, bankruptcy, in that moment, that's the only thing that happened. If you were to end in bankruptcy, one of those blank categories, that's the only result that you could have. That's a simple event. Any one of those dollar amounts, that's a simple event as well. The one that you're really interested in is down here, and that one is the theoretical probability. Now, that theoretical probability is the ratio of the favorable events. So, of course, we would love to win that, what was it, $5,000 or $10,000, whatever the highest amount was, the ratio of the favorable outcomes compared to all possible outcomes. So you're going to have a fraction. So this theoretical probability is based on mathematics. It doesn't guarantee what will happen, but it gives you a theoretical result. So these are the three things that you have to think about. Sample space, right here, a simple event, right there, and theoretical probability. That's the three things that you're going to have to focus on. So let's apply it and see if it makes sense. Well, here's our spinner, and we're going to look at it. We're going to apply those terms we just talked about. The sample space includes all of these different things here. So every single one of these positions on the spinner, we will count as the sample space, even if they repeat the same thing. So notice we have two bankruptcy places. So if you look over here at the list, this represents every single possible place you could land, right? Repeats included. The theoretical probability is going to be the total number of favorable events. Okay, that's what you want to have happen, and the total number of outcomes. Now, think of the word favorable. Favorable is usually associated with something good. It's good favor. But in this case, favorable just really refers to what is the event that you are planning, or what is the event that you are looking for. So if we were to say the favorable event is bankruptcy, that doesn't seem too favorable, but we're really interested in what's the probability that you would spin and wind up on bankrupt. So there are two of those tiles. So it's 2 over, and then if we look at all the list, there are 25 different possible outcomes. So if you think of out of the 25, 2 of those are bankrupt, 2 out of 25 becomes your probability, that's what this notation P means, that's your probability of winding up bankrupt. Now the big thing is, you can write this as a fraction, like we have here, 2 out of 25. You could also write it as a decimal. And as a decimal, we could either divide 2 divided by 25, or in this case, maybe we could make it into a bigger fraction, multiply by 4, multiply 4, and get 8 over 100. And turn that into percent, that would be 0.08, which would be 8 hundredths. So you have a decimal, or you have a fraction, or of course you could think of it as a percent, an 8% chance of landing on bankrupt. So that's one application of the sample space, this theoretical probability, and the simple event, which would be the bankrupt. Let's try another example. Let's see if we can identify some different sample spaces from this number cube. Now, if I just asked you what would be the numbers you could find on this cube, you should list 1 through 6, right? 1, 2, 3, 4, 5, 6. But if you were asked to find all the numbers that were less than or equal to 3, right here, we're talking about which numbers? That would be 3, that's equal to 3, 2, that's less than 3, and 1. This right here is your sample space. Those are the only values that meet this requirement. Look at this next one, an odd number. Well, think of again the values from 1 to 6. Which ones are odd? That makes up your sample space. So you make your set 1, 3, and 5. There's your sample space. How about a number greater than 4? If we think about that, it doesn't include 4, but it will include 5 and 6. There's 3 examples of finding the sample space. Remember, the sample space are all the possible outcomes. And with these 3 examples, we're looking for very specific outcomes. So I could have asked for all the values on the dice, but in these 3 cases, we're looking for specific results. So how many of those results meet these criteria? The last thing that you want to think about is, what is the complement of an event? And again, a complement seems a little misleading. It sounds like you're trying to be nice, you're trying to give a nice comment, trying to be good. Well, a complement really just describes everything else you're not looking for. So if you look at this definition, it's the set of all outcomes of an experiment not in the given event. That seems kind of weird, but let's think about that. Remember the Wheel of Fortune bankruptcy one, where we had 2 out of 25 possible outcomes that would be bankrupt? Well, the complement of this would be 23 out of 25. There are 23 other outcomes after those 2. If you add them together, you would wind up with 25 over 25, or 1. The fraction that you find of a complement should add up to the actual events you're trying to locate. It should add up to 1. So notice these 2 fractions equal 1. You could also think of it as 100%. And if you recall that 2 over 25 was 8%, the rest, 23 out of 25, should wind up being 92%, which would give you that 100%. So a complement describes the rest of the outcomes that are not included in the outcome you're looking for. So basically think of all the results that you aren't looking for, and that would be your complement. Alright, here we go. A box 12 yummy donuts from Dunkin' Donuts. Can't have at school, but we can watch them in math. Let's see about practicing a few of the things we've talked about today. So remember that the probability of any event is going to be the number of favorable outcomes over the number of total outcomes. So let's first look at how many outcomes are there. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yep, it's an even dozen, not a baker's dozen. So the total number of outcomes is 12. Let's say we're looking to see what the probability of just closing your eyes, reaching in, and getting how about the, let's see, these frosted jelly-filled donuts. That'd be 2 out of 12, which will reduce down to 1 over 6. Now remember, you could write that as a percentage. You could write that as a decimal. So depending upon what you're being asked to do, there's 3 different ways to answer the question. But if you think about it again, how about the 4 that kind of look alike? So maybe let's think about this guy right here, this guy right here, this guy right here, and this guy right here. There's 4 of those. I don't know if they're all the same, but let's pretend that they are. So that would be 4 out of 12, which is 1/3. So in terms of percent, that's 33 1/3%. And as a decimal, that'd be 0.33 repeating. So right there, that's the lesson on probability, calculating theoretical probability. We're going to do a bunch of that in class, so hopefully you'll get to practice. If it doesn't make sense, we'll learn about it more. Now, maybe you want to go out and have a donut or a snack, but try some of those practice problems and see how it feels.